Hi, our group today are going to talk about the separation process service learning. The topic is about distillation. So the team members including me, Joanne, Royu, Chloe, and also Li Xian. So what is the meaning of distillation? Distillation is a process used to separate components of a liquid mixture based on different boiling point. The basic process of distillation are heating, condensing, and also collection. The mixture is heated until the substance with the lowest boiling point evaporates. The vapor is then cooled back into a liquid using a condenser. And lastly, the distillate is gathered in a separate container. So this picture shows us that it is a distillation apparatus. What is the primary types of distillation? The first one is simple types. It is best for liquid with vastly different boiling points. The second one is a fractional types. It is used for complex mixture with close boiling points such as crude oil. The last one is steam type. It is used to extract heat-sensitive essential oil from plants. So what is the common uses for distillation? It can purify the drinking water, refining the gasoline and fuels, producing the alcoholic spirit and perfumes.
Next, what is vapor-liquid equilibrium? Vapor-liquid equilibrium, VLE, explains how a substance divides between a liquid and its vapor. VLE is the basic principle behind distillation. Distillation works because when a mixture boils, the vapor and liquid do not have the same composition. The vapor contains more of the components that evaporate easily, which has a lower boiling point, while the liquid contains more of the components that evaporate less easily, which has a higher boiling point. Therefore, understanding VLE is important for designing, analyzing, and controlling distillation column. VLE data for binary system is commonly represented in TXY diagram and SY diagram, where the pressure is constant. These are convenient for the analysis of binary distillation systems because the pressure in a distillation column is usually relatively constant. A TXY diagram shows temperature versus composition at constant pressure. The lower curve represents the mole fraction of the more volatile component in the liquid, X1. The upper curve represents the mole fraction of the more volatile component in the vapor, Y1. Temperature is plotted on the y-axis. Pure substances boil at a single, fixed temperature, whereas mixture boil over a range of temperatures. The bubble point is the temperature at which a liquid mixture begins to boil, while the dew point is the temperature at which a saturated vapor starts to condense. The lower curve is called the bubble point curve or saturated liquid curve, and it shows the mole fraction of benzene in the liquid phase. The upper curve is called the dew point curve or saturated vapor curve, and it shows the mole fraction of benzene in the vapor phase. At the leftmost point, the mole fraction of benzene is 0, meaning the mixture is pure toluene, and its boiling point is 110.6 degrees Celsius. At the rightmost point, the mole fraction of benzene is 1, representing pure benzene, with a boiling point of 80 degrees Celsius. Since benzene has the lower boiling point, it is the more volatile compound. Below the bubble point curve, the system exists as a single subcooled liquid phase. Above the dew point curve, the system exists as a single superheated vapor phase. In the region between the two curves, both liquid and vapor phase are present in equilibrium. When a subcooled liquid mixture with a benzene mole fraction of 0.4 is heated, its composition remains constant until it reaches the bubble point, where boiling begins. At this temperature, around 95 degrees Celsius, the vapor phase that forms has a higher benzene content, with a mole fraction of about 0.62. The XY diagram can be obtained from the TXY diagram by drawing horizontal lines between the bubble point and dew point curve. The corresponding values of X and Y are then used as coordinates on the XY diagram. The red circle represents the values at 95 degrees Celsius, where X equal to 0.4 and Y equal to 0.62, while the green circle represents the value at 85 degrees Celsius, where X equal to 0.8 and Y equal to 0.91. It is important to note that each point on the XY diagram corresponds to a different temperature. From the XY diagram, we can determine the equilibrium mole fractions of a binary mixture in the liquid and vapor phases. For example, if the liquid mixture contains a benzene mole fraction of 0.6, the corresponding mole fraction of benzene in the vapor phase at equilibrium is 0.79. The remaining fraction belongs to the less volatile component, toluene. Thus, in the liquid phase, the mole fraction of toluene is X2, which is equal to 1 minus 0.6, equal to 0.4. And in the vapor phase, it is Y2, which is equal to 1 minus 0.79 and is equal to 0.21.
Now let's move on to the application of distillation. The first application is petroleum refining. The refinement of crude oil is one of the most critical and commercially significant uses of distillation. Crude oil is a complex mixture of various hydrocarbons that are not usable in their raw state. Refineries use continuous fractional distillation to separate the mixture into specific fractions based on their different boiling points. This process extracts lighter components such as gasoline, kerosene, and jet fuel, as well as heavier components like diesel, lubricating oils, and paraffin. Large-scale industrial towers allows these different products to be collected at various stages of the column simultaneously. The second application for distillation is water purification and desalination. Distillation serves as a critical method for producing high-purity water through processes like multi-stage flash distillation for both human consumption and industrial use. In regions facing freshwater scarcity, desalination through distillation is used to purify seawater into safe drinking water. The process is also essential for creating distilled water via simple distillation that is used in laboratories and sensitive manufacturing environments. By removing minerals and salts, distillation prevents scale and corrosion, which helps to extend the lifespan of industrial machinery. The last application is food and beverages processing. Distillation plays a crucial role in producing concentrated extracts and high-quality consumables using pot distillation or column distillation. The beverage industry uses distillation to increase alcohol content and refine the flavor profiles of spirit like whiskey or vodka. The process utilizes the different boiling points of water and ethanol to vaporize and condense alcohol into a concentrated form. Industrial distillers also utilize vacuum distillation to process dairy products, refine vegetable oils, and create fruit juice concentrates by removing unwanted components.
To wrap up our session, let's quickly summarize the key takeaways about distillation. First, the basic definition. Distillation is simply a technique we use to separate a mixture of liquids. We do this by taking advantage of their different boiling points. The science behind this is something we call vapor-liquid equilibrium, or VLE. It sounds complex, but the concept is actually quite simple. When you boil a mixture, the vapor that comes off is richer in the volatile components, and these are the parts with the lower boiling points. Meanwhile, the liquid that is left behind holds onto the components that have higher boiling point. To visualize this relationship, we use spatial graphs. The most common ones are the TXY diagram, which looks at the temperature, and the XY diagram. Moving on to how we actually use these graphs. The TXY diagram is particularly helpful because it lets us see the exact makeup of the mixture at any specific temperature. You simply look at the curves. The bubble point curve tells you the composition of the liquid phase, while the dew point curve gives you the composition of the vapor phase. Beyond the charts, this process is essential in the real world. You see it on a massive scale in petroleum refining, where continuous distillation separates crude oil into everyday fuel, like gasoline, jet fuel, and diesel. It's just as important for our environment and health, allowing us to turn seawater into drinking water through desalination or create pure water for laboratories. Finally, the food and beverage industry relies on it to produce spirits, process dairy products, and even refine vegetable oil.
These are the references that we use in our project. That's all from our group. Thank you.